everyone, so here we have a first order differential equation mixing problem. So in this equation, we're going to use this equation, which is the q prime is equals to rate in minus rate out. The first thing to do is to determine the values of the variables. So for the ci, our value is equals to 0, and our qi is equals to the rate in, which is the 10 liters per minute, minus, to find C sub O, we're going to use the formula of Q over Vt. Our Vt is equals to V initial plus Qi minus Qo times T. So our V initial is equals to 100 plus, since our rate in and rate out is the same, we have 0 times multiplied by t. Therefore, we have 100 as our Vt. So we can now plug in Vt here. So C sub O is equals to Q over 100. Our Qo is equals to 10. Therefore, we can simplify this equation into this. Q prime is equal to 0 minus 1 over 10 Q. So then we can transpose this in order to have the differential equation. Q prime plus 1 over 10 Q is equals to 0. So here, we can also solve this equation. dq over q is equals to negative 1 over 10 dt using the exact differential equation. So for the exact differential equation, we're going to first prove the exactness of this equation. So to find the exactness, we're going to have the partial derivatives of m with respect to t, which is 0, and the partial derivatives of n with respect to q, which is also 0. Therefore, this equation is exact. Since we proved that this equation is exact, we're just going to integrate the equation. So, integrating this dq over q is equals to 1 over 10. Here, dt. We're going to have the value of ln q is equals to negative 1 over 10 t plus c. So we can further simplify this equation by using the Euler, which is e raised to ln q is equals to e raised to negative 1 over 10 t plus c. Then simplify this equation, we have q is equals to ce raised to negative 1 over 10 t. In order to find q, we're going to plug in the initial condition, which is the q is equals to 10 and t is equals to 0. So ce raised to negative 1 over 10 times 0. E raised to 0 is equals to 1. Therefore, our c is equals to 10. We're going to substitute in the equation acquired. Then q is equals to 10 t raised to negative 1 t. In order to solve for the problem, we're just going to substitute the value of time, which is 30 minutes, in this equation. Therefore, we have 10 raised to e raised to negative 1 over 10 times 3. Then we have the value of 0.4979 kilograms.
Another way to solve for this problem is to use an integrating factor, which is mu of t is equal to e raised to integral of p of t. Our p of t to this problem is 1 over 10. So, we're gonna write e integral of p of t, which is 1 over 10 dt, which is equal to e raised to 1 over 10 t. Now we're gonna plug this into our equation to solve for d of t, which is this one. Now to plug our values, integral of mu of t, e raised to 10, 1 over 10 t, where g of t is 0, d plus c all over mu of t, which is e raised to 1 over 10 t. To solve for this, we will only have the c e raised to negative 1 over 10 t. Now to solve for c of e raised to e, and to solve for c, we will use the initial value, which is 10. 0 is equal to 10, and we will have then e raised to c e over 10 times 0 is equal to 1. So we're gonna have c is equal to 10. So q is equal to 10 e to the negative 1 over 10 t. Now to solve for the problem, which is 30 minutes, we're just gonna plug 30 to the t. Q of 30 is equal to 10 e to negative 1 over 10. 30 is equal to 0.4979 kilograms, which is our final time.
So there's another way in solving this problem through using separable differential equations. Now we have already our differential equation here, which is the rate out is negative q over 10. Since the tank has pure water going through it, so the concentration is 0. So automatically the tank will decrease in the amount of salt. So in this problem, I could cross multiply 3t to the other side. So I will left with dq is equal to negative q over 10 dt. So q, to transfer q to the other side, I will multiply it by 1 over q. So multiplying this by 1 over q will give us dq over q is equal to negative 110 dt. So, seeing this equation, we could integrate both sides. So, let's continue it here. When we integrate dq over q, we know that this ln of q is equal to negative 1 over 10 t plus c as our constant of integration. So to get q, we will use the exponential function. So we're left with q is equal to e raised to negative 1 over 10 plus c. We could write this as e is to negative 1 over 10 times e raised to c. And we know that e raised to c is constant, so we're left with q as a function of time is equal to c over e. C e raised to negative 1 to 10, or forget t here, t, 1 and t. So, to solve C, our initial condition is the tank has 10 kilograms at time is equal to 0. So, when the time is 0, then it is 10 kilograms. E raised to 0 is 1. So, we left is 10 is equal to C. So, our final equation will be Q of T is equal to 10 E. Okay, so negative 1 over 10 T. So, we have already solved or formulate the equation to our problem. We just need to input our values. So, it says here that we will get the amount of salt in 30 minutes. So, we will substitute this by 0.30 equal to 10 E is negative 1 over 10 times 30. So, we left with an answer of 0.4979 kilograms.
Hello everyone. In here, we will see an application of the first order linear differential equation. This problem is a mixing problem which states that a tank has a pure water flowing into it at 10 liters per minute. The contents of the tank are kept thoroughly mixed and the contents flowing out at 10 liters per minute. Initially, the tank contains 10 kilograms of salt in 10 liters of water. The question is, how much salt will there be in the tank after 30 minutes? In here, we must first know what are the givens, which are the rate flow of water into the tank, which is 10 liters per minute, and the flow out of the contents from the tank, which is 10 liters per minute, and the initial amount of salt in the tank, which is 10 kilogram, and the volume of water in the tank. Then, what are the required to find the amount of salt after 30 minutes? This will be our equation to be used. Let's say Q is a function of time, which Q models the amount of salt in the tank so getting its derivative will give us the change in salt with respect to time is equal to the rate in minus rate out, which will be QI will be the inflow rate of the water and the concentration of the liquid into the tank, and Q sub O is the volumetric flow rate leaving the tank, and C sub O is the concentration leaving the tank. The concentration leaving in the tank is given by this equation, wherein Q is the any amount of salt present in the tank at any time, and divided by the volume total. The volume total is given by this: the initial volume plus the flow rate in minus the flow rate out times time. This will be the equation will be used, the concept. Then, formulating our differential equation, we will have dq over dt is equal to C sub I times our flow rate in, which is 10, minus Q divided by our total volume, which is V total, is equal to 100 plus 10 minus 10 times T, which will be 0, will be V total will be 100 times 10 times 10, which is the volume flow rate out. Then our initial concentration is 0 since pure water is flowing into the tank. This part will be 0. Hence, we'll have our differential equation is equal to 0 minus 10 Q all over 100. For our initial conditions, we know that at time is equal to 0, the amount of salt in the tank is 10 kilograms. Now, as we have our differential equation, we can now use MATLAB to solve this to get the general solution, a particular solution, and the amount of salt in the tank after 30 minutes. Which is the required. Opening MATLAB, we can now calculate the first order linear differential equation, the mixing problem. First, we must state that T is a variable, then we will use the dissolve function. The dissolve function can calculate the general solution of the differential equation. The parameters used in dissolve will be: first, input the differential equation, then use a comma to separate the initial conditions. The initial conditions will vary depending on the order of the differential equation. You can calculate higher order differential equations too. Now, to input dq over dt, MATLAB reads dq over dt as dq, then equals to negative 10 over 100. Then we will use up a asterisk to multiply q, then separate by a comma. We will now state the initial condition. Means the time is equal to 0, the amount of salt is 10 kilograms. Enter. Now this will be our particular solution for this problem. To have a clear visualization of the solution, we will use pretty answer. exp is the Euler's number. States that exp is raised to negative p over 10, then it is multiplied by 10. You can see in the answer equal. This is our particular solution. Then to calculate q 30, first we must state that q of t is equal to our answer. Then now we can calculate q of 30. The amount of salt after 30 minutes will be, as you can see, it is a 10 times Euler's number raised to negative 3. If you want the decimal part, you can use the double function, double answer. Then we will know that the amount of salt after 30 minutes will be 0.4979 kilograms.